Hello, everyone, and welcome to today's session. Today's session is about structure and function of the mammary gland. Let's dive into it. So, the mammary gland, just some general info about it is that its embryonic origin is from the surface ectoderm, and it basically contains about 15 to 25 lobules of the tubuloalveolar gland. Now, um, I know it's written 20 in this picture, but it's 25. Okay. Now, the function of mammary gland, I'm pretty sure everyone knows is milk production, but its function is basically monitored and regulated by two hormones, prolactin and oxytocin. The prolactin comes from the anterior pituitary gland and it's causes milk production in the breast, while oxytocin is production is coming from the hypothalamus and it goes to posterior pituitary in the herring bodies, and herring bodies release them when our body needs it, and they go to the smooth muscles on the mammary gland and causes contraction, which that will result in milk ejection. Now, although testosterone is not a hormone that regulates this gland, but when the testosterone gets produced, it will inhibit the development of the mammary gland in males. Now, next thing we need to know is the structure. So the structure varies between when the female is not pregnant and the female is pregnant, and also when she's lactating. Now, when the female is not pregnant, that means no breastfeeding. So we will be having an inactive gland. The terminal ductules have already been obliterated, and there will be very few lobules, and alveoli usually will be underdeveloped. Then we will have the interlobular connective tissue, which is like it's occupying most of the gland when it's inactive. As you can see in this picture on the left, you see all the light pink stainings. Those are all connective tissue. So they're quite high in terms of majority compared to the lobules that we can see. And there will be like loose connective tissue and dense connective tissue. Now, when the female is pregnant, okay, the lobule starts to get proliferated. They become active by estrogen and progesterone. They get bigger, and the ductile epithelium starts to be fully secretory. The terminal ductules gets formed again, and also the lactiferous sinuses, and the plasma cells is going to be found in that area as well, because in the milk that is being ejected, we need antibodies for the baby, because at the beginning the baby doesn't have enough antibodies, and still it cannot produce enough antibodies by itself. Okay, next we need to see a different slides based on which like this slide we can see that the female is having a mammary gland that is not active, and then the right one is a mammary gland that is active, and this is an active one, this is a lactating one. Now, what's the difference in the non-active one? We already know what it is. Between the lactation and the just pregnant female, the way I want you guys to remember this is by this picture. So when a female gets pregnant, obviously proliferation takes place. So many alveoli gets developed. So they become like this, if you can see in my cursor. However, when milk production gets started, all these alveoli gets filled with milk. So that's the difference between a pregnant female and a female who's also lactating as well. Now, breast milk. We have 3 stages of the milk that is being ejected from the mammary gland. The first one for the first 7 to 8 days will be called colostrum, and then it will be transitional milk and mature milk. Now, cholesterol milk, its content is very, very important. And I advise you guys to especially memorize these contents. The contents, the main important ones are going to be the lactiferin, comes from lactation, and immunoglobulin A and leukocytes, also vitamin A, K, and B12. The epidermal growth factor is also important, but you can just mention growth factor, and that should be enough. But these other 6, they're very important, and you should know it by heart. Now, terminal duct lobular unit. If you guys can see here, each gland is subdivided into lobes. So these are the lobes. And then each lobe have their own secretory alveoli and also terminal duct tubes. There will be interlobular connecting ducts, and also there will be like the interlobular stroma, which has loose connective tissue and so forth. But important thing is to remember is that the interlobular connective tissue is going to be quite abundant in, as I mentioned before, in an inactive mammary gland. And when we will have an active mammary gland, it will also be present, and but it will not be quite visible. That's what I'm getting at. So remember that. Now, epithelium of the glands, there will be the name for it, it's lactiferous epithelium, which is another name that is given for that area for stratified squamous epithelium, which obviously when it gets close to the surface, it becomes keratinized, especially near the nipple. Now, lactiferous sinus is epithelium of it, it will be stratified cuboidal epithelium throughout its course, but when it's getting close to the exit, to the lactiferous duct, it becomes simple cuboidal epithelium. You guys need to know the ductus system. You need to memorize it for this for the mammary gland, and that will be interlobular duct, which forms the mammary duct, lactiferous sinus later, and lactiferous sinus drains into the lactiferous duct, which after that it will allow for ejection of the milk. Now, this is a good picture for you guys to remember. Like if you see my cursor, here is the interlobular duct, then here is the large mammillary duct, the lactiferous sinus, and finally the lactiferous duct. Now, what is areola? Areola is basically the darkly stained circle which is pigmented, and it's around the nipple. And you guys need to remember the type of gland that it has. It has sweat glands, sebaceous glands, and also very important for you guys to remember, Montgomery glands, which basically is a modified mammary gland, and its main function is lubrication, and also their secretion causes the change of pH on the skin of that area. That's everything you need to know about areola, and this is sort of comparison between the 3 stages we talked about. So when the mammary gland is inactive, when it's the pregnancy have started, so because of estrogen and progesterone, it is getting proliferated, and the lobules are getting bigger and bigger, and more lobules are getting formed. However, milk production have not started yet. Lactation or milk production, it starts by prolactin and oxytocin, which oxytocin causes contraction of smooth muscles around that area and ejection. Next, we will have another sort of illustration of when the mammary gland is inactive and when it's during pregnancy, so active. You guys can see like this, you can rarely see lobule here, but here it's like quite a lot of lobules here is present. This one is more zoomed in than the right one, bear in mind. Another way for you guys to see the difference is for the interlobular duct, which is quite closed in this inactive, but in the active one, it's quite wide. Now, for the nipple, personally, just I would remember that the nipples are epidermal ridges. They are heavily pigmented. They have sebaceous glands, and they have bundles of smooth muscle around them, around the lactiferous ducts, which when the oxytocin comes, they basically get contracted and causes ejection of the milk. Nice. And obviously, sebaceous glands is also present. Here we can see in this slide illustrating it pretty well. And this is another slide you guys can see. Sebaceous glands is quite visible here on the left, and here we can see the lactiferous duct immediately before, the ejaculation or ejection, not ejaculation, ejection. And yeah, that will be the end of my presentation today. I really hope you guys enjoyed it, and feel free to contact me if you had any questions.